Hello everyone, and welcome to the 8th Field Notes Live event. My name is Betsy Schug, and I'm a field soil scientist located in St. Paul, Minnesota, and the Field Notes North Central Region representative. As a regional representative, I serve on the Field Notes Review Committee. The Review Committee solicits and selects topics for each webinar. We have selected 2 exciting topics for you today, and we encourage you to ask questions at any time using the Q&A panel. The Q&A panel should open by default. However, if for some reason your Q&A panel is not open, simply click on the question mark icon located on the right side of your screen. For closed captions, turn on the live caption button located in the lower right corner. Today's session is being recorded. Recorded sessions are available in Teams on the Field Notes channel and the National Soil Survey Center's YouTube channel. Again, thank you for joining us. I hope you enjoyed today's session. With that, I'd like to turn it over to Dave Hoover to tell you a little more about today's webinar. Dave?
Thank you, Betsy. Hi, this is Dave Hoover, Director of the National Soil Survey Center. Welcome again. Oftentimes I lead off with stories of bygone eras when we had no such communication tools like we do today, but I'll skip stories of pre-telephone eras and just say how incredibly grateful I am for the people that are presenting at these. These are folks that have taken some time out of their busy schedules to prepare materials to share with a grateful nation. And I think they've been great. This is number 8 already. It's a good collection. I was on the archive website the other day and looking at all of the notes that are out there. I was on a session where we were talking about how we deliver training to our agency, and I brought this particular field notes assembly up and let folks know that this is one of the things that we do to reach out and share information with the rest of the discipline and the rest of the agency. So very grateful to everybody who attends and who presents also. So with that, we'll start off with our first presentation for today, and that's Andrew Conlin from the Chico, California office, who is going to be talking about evidence of an extinct lake and rapid drainage features. Andrew, the floor is yours.
Hello, everybody. I'm going to give a little bit of a mapping story from some recent NOCOM mapping up in northeastern California. And this is this cover photo here. You're standing on the ridge, a northern ridge of some metamorphic Sierra Nevada mountains in MLRA 22A. And you're looking north towards Lake Almanor and the volcanics of the Cascades in MLRA 22B. The subject area we're going to be talking about is kind of in the center left over here, and so that's Lake Almanor there, a good landmark. And on the horizon are several volcanoes up in and around Lassen Volcanic National Park. That is Lassen Peak there on the left, that's sticking out a little higher. Here is just for seasonality. There's a webcam near where this photo was taken, and this is the image from this morning. So there's Lake Almanor, so you can see several feet of snow have fallen there in the last couple days, which is a real good sign. Just for a little bit of veg context along with the geology context, this is pretty much a Sierran mixed conifer forest, mostly white fir and ponderosa pine with some incense cedar, sugar pine, and on these Sierran slopes you get some Doug fir and some dogwood that you don't get generally on the volcanic flats that we're going to be looking at as we zoom in. Lake Almanor is a man-made reservoir completed in 1914 for hydro power, and before it was a lake, it was Big Meadow, and Big Meadow was elevation was about 4,300, and Lake Almanor today, the reservoir is 4,500 feet. It was speculated by Cordell Durrell, a geologist, in his book Geologic History of the Feather River Country, California, that he speculated that there was about 150 feet, a lake that exists, a natural lake that exists, an extinct lake that existed here that was about 150 feet higher than the present 4,500 foot of Lake Almanor. So I'm going to progress on. I think that covers that. So I'll give it some regional context. Here's a map of the Pleistocene pluvial lakes in the Great Basin. So over here is Lake Bonneville in Utah, and then there's the Snake River Plain, and then here's Nevada in the center, and Lake Lahontan, a large lake in northwestern Nevada. And my presentation area is off in that yellow circle, and these pluvial lakes were generally internally drained. And this area that I'm talking about, it's externally drained by the Feather River down into the Sacramento River, out into the San Francisco Bay. So there's similarities and differences, but you can see it's right on the edge of where these well-known Pleistocene lakes are. And a lot of times these are more in a desert environment and probably a lot more easily observed as far as the relic features. Okay, so starting out with some micro clues, I started seeing some of these sorted gravels scattered about in this mapping area, and sometimes they were concentrated in a setting like this on a saddle up on a basalt scarp. So that became kind of intriguing to think about some water influence up on some higher areas. And these gravels are somewhat rounded and certainly sorted, and they look like beaches that you can find on present lakes in this area. Okay, I'm going to go through some standard map imagery for the area. This is Lake Almanor here, and the black line is this convoluted not-com area that I was mapping. And so on the right and around on the bottom is a Forest Service soil survey area, and then north of this black line was an NRCS private land soil survey. And this area was never mapped because it was in the Forest Service soil survey area, and it was private land, and they chose not to map it. And so the private land survey adjacent to it, it wasn't in their survey, so it wasn't mapped either. So it became all mine after everybody retired. So here's this red line, and this presentation ended up being to substitute for a field trip that was going to happen with the California Forest Soils Council in 2020 that was canceled due to COVID. So this presentation is the online version of that. And what we were going to do is just walk this 1 mile line to look at some different features and characteristics that play into the story that I'm going to try to tell. Okay. Couple things here. There's a blue line, a custom contour blue line, and a custom contour purple line, and those are my estimates of where this high lake level occurred. And you can see sometimes they correspond to, you know, the slope breaks nicely, but somewhere around those edges is what I started thinking about as the elevation of the water in this extinct lake that I will try to unfold. So again, the black lines are the mapping area. So you can see the standard topography, and we're going to look at some other images that might show some things better. So yeah, just to reemphasize, these ridges down here in the bottom center, those are Sierra Nevada metamorphic ridges. And then starting right about here and going on all over to the west, that's volcanics, and you're at the base of a very large volcano here that is not in this screenshot, but it's off to the west. Okay, so here's standard aerial imagery for the same area. And a couple things I'll try to point out here. This feature here, this wet meadow, is kind of unique. You have Butt Creek is draining across this map here in this direction down into another reservoir here. And the way this meadow is perpendicular to this creek kind of puzzled me from the beginning. And then as I got up in here, there's not a stream in that meadow either. So that was one of the early clues of there was something odd going on. And now here's kind of bare bone hillshade from a 10-meter DEM with that same 1 mile walk line across here. So again, you can see Buck Creek flowing across here. You can see that's where that meadow is. And then there's some other features that are kind of intriguing. You kind of have this oval shaped cove over here. And you can kind of see, it looks like there's maybe some things missing here in the center compared to over to the east and then over to the west. So when I first started, I did a couple of pits up on the basalt flows and figured, okay, there's nothing to see here, just plain old basalt flows. And then I progressed on to the more varied geology of the Sierra Nevada to start getting documentation for some of these other soils and geologic bodies within this area. And move on. And so then I came back to work that boundary to get some better documentation with pits to see how well my observations were going to correlate with existing mapping. And I kind of noticed that the topography was kind of odd in here. There's no streams and there are closed depressions. And it was also a little bit difficult to navigate because you really, I think subconsciously, we use streams to orient ourselves no matter where we are. And in here, there were no streams. And I would notice that driving around, you could all of a sudden you'd be going down and then come back up out of these closed depressions, which was odd to me. And that's the hydrography, the blue lines there, just to show you that there's nothing registering here, and some of these streams kind of come down and die in these flats here. So again, just the bare bones, kind of showing you the topography of the area. And what you can see is there's dip slopes, these nice gentle ramps, and then scarp slopes. And you can see that on the Almanor Peninsula. You know, the east side is kind of gradual, and then it drops off, you know, to the west. And the same with these ridges here. And then you can start to see that there's some of these scarps that are facing east. And that seemed to be odd as well, especially without streams. So you thinking about the lake level and thinking about some of my observations and some of these slope inflections, I started trying to envision what would have happened as it drained, and again, this kind of mysterious area in the middle. And as the lake initially drained, it was going in all directions, and you know, probably kind of a laminar flow. And this big blue arrow in the lower right here, that's the North Fork of the Feather River. So lots of water would have been going out this way. And then here is this water gap in between these Sierran ridges, and it's also a nick point. It's a significant elevation drop here. And so there was also water draining out through here. And as the lake level lowered, the local topography started impacting and concentrating water towards this nick point to possibly make some of these features that were puzzling me initially. And so what I have these PPs here, that'd be a plunge pool in that meadow that's perpendicular to Butt Creek. And then I have another one here that's in that kind of oval scalloped area into that basalt plateau there. So there was lots of different dynamics and kind of, you know, deep physics as far as the chaos of swirling water and then the water adjusting to the topography as it lowered. And then this little light blue line is we'll come back to that. That's gonna represents an area that has a kind of a charismatic, sensational feature in regards to this story. So I'm going to go back. So we're going to start on this red line. We're going to start on the east end of it and move across it to look at some of the soils and that I encountered along this transition from this stable lake bench, which seems to be pretty preserved as it was by the lake bottom, versus this area as you cross this line into this corridor where there was a lot of dynamic drainage activity. So this is on the east end of that line. This is a uniquely very fine soil for this area. So I attribute it to deep water lacustrine sediments with silty clay textures and greater than 50% clay. It's kind of a surprise to see here. And this is kind of a wet area that some in this area call vernal pools up here. And it's basically grasses and forbs with some lodgepole and certainly not the Sierra and mixed conifer forest. And you can see I have the photo of the pile here. As hole diggers, you all can see the strong aggregation representing those fine textures that I encountered here. And now we're going to move just a little bit to the west and still on this stable lake bench. And now here you are, and just a slight rise above that previous area, and now you're in a Sierra and mixed conifer forest. And so what I determined here, we had, this is still on the stable lake bench with shallow water lacustrine deposits with loam textures over the deeper, finer lake sediments underneath. And so you can see, I think this red line here is where I started hitting with the auger, starting hitting those finer soils like the previous profile. So these were probably shallower water deposits that washed around with some redeposition as opposed to the stable deep water deposits. Okay, now we're moving over the edge, over the brink into that drainage corridor, and this is a soil that represents the dip slope on the basalt. And so you don't see any real obvious lake sediments here. And what you do see is you have a core here, and then you have rines around it. So I see this as a good example of spheroidal weathering. And even this upper one looks like it could be a relic of spheroidal weathering as well. So you can see these concentric rings of rocks around the bigger cores. And this one shows up in the bottom a little bit better, kind of like an onion. And so that's, not unusual for basalt that, fractures into columns, and then the columns fracture into segments. And then the segments start to weather, and their corners weather away because the weathering front is on two sides. And then they'll start to generate these more spheroidal cores that just start to concentrically weather. And the weathering rines are what end up being, the soil itself, the fines. So this is, I can use this this clue as this looks like it's fairly stable and more residual soil, although it had some dynamics moving across it. Now, within that drainage corridor, this is on the Scarp Slope versus the dip slope. So this is a more convex position, shallower, rockier, and even less apt to have retained any of the lake sediments, even if they flowed across it. And another typical soil in that drainage corridor. And now moving on to the flat areas within the drainage corridors, which exist as in subtle concavities and as well as in narrow linear bottoms between those bedrock structures that those previous soils were on. So these are sandy loams versus a stable lake bench, and there's a few rocks in there, but not nearly as many. And these are really sweet spot soils within that setting. You can see they're a lot more productive, less rock fragments, nice and deep, and very unique. And when I started seeing these even up on tops of the dip slopes, it started to really make me think about some of the dynamics and the patterns that weren't making sense, and to better understand those patterns, to design map units as well as components. And here's an area that there were some scoured flats within that drainage corridor that literally had 0% slope, which was, you know, that kind of surprised me, because most of those dip slopes have at least, you know, 2, 3, 4% slope. And this was there's a few of these areas that were flat, and this one I attribute to having about 40 centimeters of redeposited lake sediments with, you know, some of the sorted gravels over the residual basalt flow that was scoured. And this bowl shape of within the rock fragments intrigued me, and it seemed too small for a wind throw. And going back to the spheroidal weathering, I know it's a wild stab, but that maybe one of those cores was plucked out of here by the dynamic of possibly a vortex as that water gathered near the nick point and the water gap in this local area of drainage. So all this happened within the lake footprint, not like the channel scablands, which were below the lake. So now I did all that mapping, and I came up with those ideas, and completed the mapping, and later it was discovered that there was LiDAR here, and so after the fact, and I was being pretty resistant to, you know, in the no do-over modes of mapping, that you know, maybe someday I'll download that LiDAR and look at it. And a coworker, Jackie Vega, was nice enough to have she happened to download this just a few weeks ago, and I got to looking at it, and it was to me, it was really good confirmation of some of these features. So here's that perpendicular meadow that goes into Butt Creek there without a stream. And so again, you can almost see these basalt flows were sort of feathered by some sort of force here, and other plunge pools. And then here's that scallop kind of oval cove there that was very interesting as well. And it has a little outlet. And again, there's no stream in there today. There's no streams in any of this. So you can see this nice flat corridor here, and then these little scoured grooves. There's a whole series of them there. And so this is where we started on the stable lake plane. And then in this slide with this elevation ramp, right about here, you start getting into the bedrock controlled dip slope. And then you get into this wild corridor that was, you know, basically ravaged by water as it focused to go through this water gap. And these little blue arrows here are places that are kind of the to me, a really good clincher of the energy and the dynamics that happened here. This photo in the upper left is a basalt scarp that was cut, and it's nice and smooth as well. It's not jagged, you know, angular basalt like you usually see. And there are no streams here. There's no channel. And that picture is taken right there at that blue arrow on the left. So you can see there was a scarp here, you know, bedrock structure, and it was cut, and it was cut smoothly. And then there's another one here that that you can barely see on the LiDAR image, and that was filled in for road grade. So that's not even, you can't really see that. I tried to show that to a couple people, and they could see it in the field, but it was filled in with boulders and stones to make a flat, you know, log road grade. So it's hidden, but this particular feature is one of the more showy clues in this whole dynamic that I came up with to understand this at first mysterious pattern that then became more clear over time. And so here's just a big zoom out picture. That's Lake Almanor there, and this yellow circle is this area that we've been talking about. And those custom contours are on there, and as these brown lines to give some shape of how convoluted and extensive this would have been if it was a lake. And as I looked at these lines, this area down here became the pinch point. That's where they became closest together in the North Fork of the Feather River Canyon. So this is just fodder for the future. But what caused this lake that wasn't in an internally drained watershed became something to speculate about. And I do know from mapping over in this area years ago that this is heavily glaciated over here. You can see all those little glacial lakes up in there. And then over here as well, these are tarns up on this nice glacially cut slope here on the other side of the river. And my best guess is that there could have been outlet glaciers that came down this canyon and even could have come from this other side to have just temporarily impounded water to have caused this pattern. And you can see the slope inflections match pretty nice. And places like this is a very underfit stream that, you know, in this wide valley here with these flat benches. So that's my best guess at what impounded the water to make the features in my small area of this very large dynamic. And that's it. Any questions?
Thank you, Andrew. It's a great presentation. I liked all of your thought processes and your detective work that you went through to figure out what it is that caused that landscape. So great talk.
Thank you.
Do have one question for you, and that is, what is the time period of the high water line? Was it Pleistocene or less than 15,000 years ago?
My best guess is maybe the last glacial maximum around 20,000 years. And probably a lot of that could be parsed out in the future.
And I like your never go back philosophy. It doesn't always work. What's the next thing you're going to go back and investigate more?
Oh, in this area, there could be a lot of update, and the Forest Service soil surveys there are generally pretty coarse. So maybe applying some of these concepts to that could be helpful in refining that mapping.
All right. Well, I don't see any other questions. So again, thank you for your presentation. And if folks do have questions, they can continue to ask them in the chat, and we'll get those answered and posted to the website. Okay, before we go to our next presentation, I wanted to remind folks that our next webinar is set for January 11th. So after we've all had a good holiday season, come back and treat yourself to another set of good talks. And with that, we'll go into our next presentation, which is by Nathan Rowe from the Sonora, California office, talking about the Sierra Nevada to the Alaska range, an ecological site specialist resource exchange between regions 2 and 13. Take it away, Nathan.
Hi, everyone. My name is Nathan Rowe. I am an ecological site specialist in the Sonora, California office, and I'm going to be talking about an ecological site specialist resource exchange between regions 2 and 13. So that is the Southwest region, region 2, and region 13 is the Alaska region. So I'll briefly describe our resource exchange, and this will be the only slide that is all text. Most of it is photos and intended to be enjoyable. So the details of our resource exchange, it's essentially ecological site specialists from Region 2 are going up to Region 13 to assist with fieldwork. And this is an agreement between the regional directors and the regional ecologists of Region 2 and Region 13. So what is the benefit for Region 2? In the past approximately 6 months, Region 2 has had 4 new ecological site specialists start working. And there is an online AgLearn training on ecological sites, but there's really no replacement for working with other ecological site specialists, and particularly more experienced ecological site specialists. So this has provided the opportunity for new ecological site specialists from Region 2 to go up to Region 13 and work with more experienced ecological site specialists from there, as well as meet our fellow new ecological site specialists as we've gone up there in groups. And the benefit for Region 13 is that Region 13, Alaska, has a short field season. When it is the field season, they really want all hands on deck, particularly with the Soils 2026 initiative. They have a lot of work to do, and so we have assisted with field data collection. And then there's another component to this, which is the Sequoia and Kings Canyon National Park Soil Survey was recently completed. And there's still some ecological site work that needs to be done on this. So the regional ecologist from Alaska, Jamin Johansson, is helping myself with some of that work. He's going to be coming down to the Sonora area, helping with some field work, as well as helping remote to help further develop these concepts and get the ecological site work completed. So just a little bit more on this Sequoia and Kings Canyon National Park work. This soil survey was over 800,000 acres. It encompassed 2 MLRAs. That's the Sierra Nevada Mountains and the Sierra Nevada Foothills. Both of those are within the area of responsibility of the Sonora office. It encompassed 8 LRUs. Thus far, 65 new ecological site concepts have been developed, so a considerable amount of work has already been completed on these ecological site concepts from our previous ecological site specialist, Dave Evans, and a contractor who also did considerable work. So Jamin and I will be kind of refining those concepts and just bringing things to completion. And this soil survey took approximately 9 years to complete. So for the remainder of the talk, I will discuss some of the field work that we've done in Alaska. And I'm going to break it down into a few different concepts that I think kind of embody what I took away most from this experience. The first one's going to be learning about the soil survey. The second one is about ecological site descriptions. And the third one is learning about geomorphological concepts. So this provided, particularly for myself, a unique opportunity to learn about the soil survey, and especially initial soil survey. The Sonora office is not currently working on initial soil survey. So this has allowed me to see what that process is like. Actually had the opportunity to see the landscape from the air, and then see how transects were put in across the landscape, to see how map unit components and map units were developed. And this was really informative. Some of you might be aware that ecological site specialists have been working on the Provisional Ecological Site Initiative, and that is an effort to correlate map unit components to ecological sites. And having this opportunity to see initial soil survey to understand how map unit components are created, how map units are created, was really important for understanding some of the data that I'm seeing in NRCS, like low and high and representative values for characteristics of map unit components. And so having this experience was really useful to helping me complete this PES initiative and understand the data that I was working with. And in addition, I was really impressed with how Alaska conducted their soil survey and ecological work. It was very integrated. We were on the sites with the soil scientists, and there was a conversation back and forth between ecologists and soil scientists. They would ask us, what we were seeing in the vegetation, whether there were indicators of disturbance history or moisture regime or indicators of soil nutrients, things like that. And I think having the soil scientists and the ecologists there together, both collecting data, really helps to make a product that is tied together right from the ground up. And then we also had the opportunity to learn about ecological site descriptions. So we were able to work with more knowledgeable ecological site specialists. This photo in the middle is of Blaine Spellman. He's the ecological site specialist from Fairbanks, Alaska. And Blaine's been doing this work for quite a while. He's very knowledgeable about ecological sites and the species in this area. It taught us about species like the moss on the right, Polytrichum, which is an indicator of fire, so we could have indication of previous disturbance history at these sites. On the left, we're aging a tree by counting the rings. This is a white spruce that's about 144 years old. But we'd see other white spruce and black spruce about this size, some of them older than 250 years old, and using that type of information to understand the productivity of a site, what type of soil nutrients might be in the area, and how to distinguish ecological sites based on some of those site index type values. And then it was also really informative while we were working on that initial soil survey. We're also collecting the first ecological data for these areas. And so we went through that process, and Blaine recently came up with some first drafts of ecological sites from that work that we did. So he shared that information with us. So we got to see from the data collection process and to kind of the creation of some of these ecological sites, how that all fits together to kind of give us a holistic idea of how this process takes place. And then we also had the chance to learn a lot about geomorphology. I'm from New Hampshire, which is kind of an older landscape that's highly eroded, very vegetated. And this gave us the opportunity to see really clear, geologic and geomorphologic concepts. This photo on the left, that's Denali in the background with the Nenana River right near the confluence of the Nenana and the Tanana. In a really flat valley and really broad floodplains. We're working in the floodplains of those rivers during the soil survey and seeing the way that those processes influence the soils in that area and the vegetation in the area. And then the photo on the right is also near a confluence. That's the confluence of the Copper River and the Chitna River. And in this Copper River basin, there was a large glacial lake, kind of similar to the events that took place with the Missoula floods, where you had kind of a glacial dam keeping this lake together, and you have large lacustrine deposits, and you see a few ecologists here walking on some of those lacustrine deposits that these rivers have now cut down through, and seeing the way that past glacial events and these geologic processes have altered the landscape. And then we also had the opportunity to learn about new ecosystems and see amazing places and just kind of enjoy, the work that we're doing. This photo on the left is actually up on top of some of these lacustrine terraces, and it's these broad, wet areas with open water or wetland complexes or boreal forest, and really surprising to see that much moisture kind of perched on top of these bench features. And then the photo on the right is a mountain in the Wrangell St. Elias range, Mount Blackburn, and this is a mountain over 16,000 feet. It's just broad boreal forest as far as you can see. It's the largest designated wilderness area in the world and a really impressive mountain range. I've always wanted to see the Wrangell St. Elias Mountains. I worked in Sitka, Alaska a while back, and it's basically always raining there, but on one of the clear days, I was able to get up high and I saw a mountain out in the distance, and it was Mount Fairweather. But of course, at that time, I figured it must be Denali because I thought Denali was the only mountain in Alaska. But yeah, ever since I learned that the Wrangell St. Elias mountain range existed, I had always wanted to see it. So we got to see the northern extent of this mountain range, and hopefully I'll get to see more at some other time. So yeah, this is that's me on the left, and Tyler Netz, the ecological site specialist from Arcata, in the middle, and that's Jamin Johansson on the right, the regional ecologist in Alaska. And if anyone has any questions, I'd be happy to answer them.
Thank you very much. Good presentation. Great photos too.
Thank you.
I'm not seeing any questions in the Q&A pod there. Let's give it just a sec, see if folks were so involved in watching your presentation that they forgot to ask their questions. Where's your next big desired place to go to?
Oh boy. Well, I'd love to get onto the North Slope in Alaska, like up near the Arctic National Wildlife Refuge. Yeah, in Alaska, and then in the continental U.S., I've never been to the Wind Rivers. I would love to get there.
I've backpacked there. It's a nice country.
Yeah, have you? I hear it's amazing.
Nope, not seeing any questions, Nathan. So
Okay,
again, if people have questions, they can certainly put them in the chat and they will get answered. And then just a reminder to folks that the next webinar is January 11th. So thanks to both presenters and thanks to folks for tuning in. Talk to you in another month. Bye now.